Hi grade 9s, we are on Unit 3, Day 3 lesson, and we're going to be talking about solving polynomial equations. In today's note, we're going to continue with what we were doing in Day 1 and 2 with solving equations, but we're going to add in cases where you maybe have to multiply a monomial by a polynomial. So this is similar to what we did in the Unit 2 work, but we're adding that into our solving equation skills. So again, like in the previous lesson, there is a warm-up. This one has 3 different questions from the Day 2 work. If you guys can pause this video, please, go off and try the 3 questions on the warm-up. Give those a shot from your from the note that's linked in the Google Doc for your outline, and then unpause this video to continue on and check your work. So please try these questions first, try them on your own, and that will give you a better picture of how well you understand the Day 2 material before moving on to the Day 3. So if you're done those warm-up questions, here are the solutions for you to check. So the first one, a plus 5 equals 3a minus 9. Remember, we want to get all of our variables to one side and the numbers to the other. So I have a minus 3a equals negative 9 minus 5. Negative 2a is negative 14. And dividing by the negative 2 to undo that multiplication, we get a is positive 7 in the answer. Similar for b. Remember that the sign in front, we want to be able to undo that. So I have a negative m here. That would be like a minus 1m. I have to do plus 1m, which is undone on the right-hand side and ends up on the left. We've got 3m plus 4m, and then the plus 4 gets undone with a minus 4. And negative 28 minus 4 is negative 32. Dividing out by the 4, we get m equals negative 8. The last example has more terms, and you could actually add your like terms before you start moving stuff. It adds an extra step, but it makes for less manipulation in this moving the variables to one side, the numbers to the other side. There's just kind of fewer terms to move. So it's up to you whether you want to add your like terms first or to move things first. Either way should end up the same answer. So here I get 8n plus 3n that I had, and I'm undoing this plus 4n with a minus 4n, which will zero out over here, but I'll have a minus 4n on the left. Then here I had 20 plus 10, and I had a minus 19 that I have to undo with a plus 19. We end up with 7n equals 49, dividing by that 7 times m to undo the multiplication, and n is 7. So we're going to move along into our first example, and in this one we basically see that we've got 7 times 4 minus y equals 42. We're adding a step to the start of our questions. So this is going to be done before we do any of the work that we did in the previous day's lesson. We're going to just multiply in to get rid of the bracket. So we're multiplying this monomial 7 by the polynomial 4 minus y in the bracket. We're always going to do that multiplication first before we start doing any other kind of solving equations. So it's just kind of adding in this multiplication step or distributing out the brackets. Remember, I said sometimes we call it like rainbow because when you draw those arrows, it kind of makes a rainbow. So 7 times 4 is 28. 7 times 1y, remember that there's a 1 in front of any variable that doesn't have a coefficient. Multiply the coefficients, so 7 times negative 1 is negative 7, and add any exponents on the variable, but there's no variable with the 7, equals 42. So from here, it's just like one of the equations we would solve previously. So I need the numbers to go on the right-hand side, so positive 28 is undone with negative 28, which I'm not going to write there, but I would have 42 minus 28 over there. So negative 7y equals 14. And then we need to undo this multiplication by negative 7, and I'm going to divide by negative 7. And y equals negative 2. So the reason I always do this division, or try to, in a different color, sometimes people kind of think of this as like one step. So negative 7y equals 14. The next step is dividing, and I want it to be clear that that division is a whole separate step, but I'm a little bit too lazy to rewrite the negative 7y equals 14 with the division in a whole separate step. So I'm kind of showing with the color change that dividing by negative 7 on both sides is the next step of the work in the equation. Similar again here, we have 7 times this bracket on the left, and then negative 8 times this bracket on the right. So we're going to distribute the brackets. We're multiplying this monomial into the polynomial in each bracket before we start trying to isolate and solve. So 7 times 4 is 28. 7 times negative 3z is negative 21, and we still have a z. And then negative 8 times 2z, negative 8 times 2 is negative 16z. Negative 8 times negative 1, careful with your integers there, is positive 8. And my z's look a lot like 2, so I have to be careful on this one. So now we're back. This line here looks like a question that you would have done yesterday. So here we've got negative 21z, which is going to stay the same. And then this negative 16z would get undone by positive 16z, which will happen over here, but it would have zeroed out over here. Then I have an 8, and I have a 28 here that would have to get undone with a minus 28. So negative 21z plus 16z is negative 5z. 8 minus 28 is negative 20. And then I'm going to divide each side by the coefficient there. I have got negative 5 times z, so I'm dividing by negative 5. And I get z equals negative, and negative makes positive, 4. Next one. Sometimes you don't have brackets on both sides. Wherever you see those brackets, that's where you're going to distribute before you start your work of solving. So I'm going to distribute a negative 3 into the bracket where we've got it. The left-hand side of this equation is just p plus 23. Nothing to do there. You have to distribute the bracket, multiply that monomial in before you start trying to solve. Negative 3p, negative 3 times 3 is negative 9. So now we're back to a question that we would have had in yesterday's work. So I see I've got a negative 3p here on the right that I want to be on the left. So I'm going to do plus 3p, which would zero out. And then I'll have that plus 3p over here. I have a plus 23 that I want to get rid of on the left. So it's going to have a minus 23, which would be on the right. The minus 23 here would zero out. Remember that just p counts as 1p when you're adding like terms. P plus 3p is 4p. Negative 9 minus 23 is negative 32. And then I need to divide, because I have 4 times p, so opposite operations of 4 times something is dividing by 4. So I get p equals negative 8 for my answer. So all of these are going to be very similar. You're just adding on a step at the beginning where you're multiplying the monomial in front times the polynomial in the brackets. Here we go, next one. Negative 5 times 7, negative 5 times negative 2m. And here I'm going to use a different color just to make it really clear. The negative 5 multiplies by this bracket, this polynomial in this bracket. This 3 is going to multiply the polynomial in the second bracket. So negative 5 times 7 is negative 35. Negative 5 times negative 2m is plus 10m. 3 times 8 is plus 24. 3 times negative 4m is negative 12m equals 21. So at this point, we could just move all of my most of the examples I've done, I've just said, oh, okay, I want to get all of my variables on the left and all of the numbers on the right. But if you have a lot of terms and you see some like terms, you can do your like terms in a separate step, just to kind of clean things up a bit. I'm going to add my m like terms. So 10m minus 12m is negative 2m. And then I have negative 35 plus 24 as my numbers. So I get minus 11. So you can do kind of move these first or do like terms first, whichever you find easier, but just to kind of show you both ways here. So now I have negative 2m minus 11. I have to undo this minus 11 with a plus 11. So negative 2m equals 32. And then I'm going to undo my multiplication, multiplying by negative 2, undo that with a divide by negative 2. Careful with your signs here. Positive 32 divided by negative 2 is negative 16. Okay, my last question is another geometry one. We're going to have to set up kind of some equations based on this word problem. So it says that a square has side length 3k plus 2. So I'm going to draw that out. I'm going to draw a square. And I'm going to label with those little tick marks to show that each side is the same. And I'm going to label this 3k plus 2. Then it says an equilateral triangle. So remember, an equilateral triangle is a triangle where all 3 sides are the same. I almost said all 4 sides. There's not 4 sides. All 3 sides are the same. And notice I'm doing 2 tick marks to show it's different than this one, but all of these with the 2 tick marks are the same. And they have side lengths of 5k minus 2. So we know that the total perimeter is 110 units. Find the dimensions of each shape. So we know that the perimeter of this one, just to kind of right under here, perimeter, we have 4 sides. The perimeter is 4 times 1 side length, right? Whatever the side length is, you multiply it by 4. And for an equilateral triangle, I know that the perimeter would be 3 times whatever the side length is. So these are the perimeter of each shape, but we know total perimeter is 110. So I'm going to combine those together and make an equation that's equal to 110. So I have 4 times the square side length of 3k plus 2, plus 3 times the triangle side length of 5k minus 2, that equals 110. Now that's a good equation. This looks just like what we were doing in the lesson today, right? I'm going to multiply the 4 into the first bracket. I'm going to multiply the 3 into the second bracket and then solve this equation. So 4 times 3k is 12k. 4 times 2 is 8. Then 3 times 5k is plus 15k. And 3 times negative 2 is negative 6 equals 110. So this one, in the previous example, it was very similar, and I solved first. I did like terms and then I moved stuff. I'm going to show this one the opposite way because it really doesn't matter whichever way you prefer. I'm not going to do like terms first. I'm just going to get the variables on the left and the numbers on the right, and then you can see the difference between this and the previous example. You choose which works best for you. So here, variables stay on the left. 12k plus 15k, that's all staying. I have a plus 8. I need to undo that with a minus 8. It would zero pair there. So over here, I'm going to have a minus 8. Here I have a minus 6. I would have to undo that with plus 6. That would be a zero pair, so I'm going to have a plus 6 on the other side. So you can see the difference here in those two solutions. So here we get 12k plus 15k is 27k. And 110 minus 8 plus 6 is 108. Dividing out to get k by itself, I have 27 times k, so I have to divide by 27. I get k equals 4. Now, is k equals 4, is that the answer to the question? Always go back and think, what am I being asked? Because a lot of people would say, woohoo, I did it, k equals 4, I'm done, but you're not done. You have to read the question really carefully. Find the dimensions of each shape. Is the dimensions of the square and the triangle k equals 4? It's not. You're going to need to use that k equals 4, and this is kind of the easy part, and put it in and find the side length of each one. So for the square, your side length is 3k plus 2, so I'm just going to sub in a 4 there. 12 plus 2, which is 14. And the triangle is 5k minus 2, so 5 times 4 minus 2, and 20 minus 2, which is 18. So that's going to be your answer. So therefore, the square has side length 14 units, and the triangle 18 units. Now, one thing you absolutely should do, if you have a word problem like this, especially on a test, you want to check your work. There's an easy way to check your work. If I get, I'm just going to kind of do this on my calculator here. So if I am told, or I solved for the side length of this as 14, 14 times 4 sides here, I get 56. And for this one, I solved for the side length as 18. So 18 times 3 is 54. So just double checking, 56 plus 54, if use your calculator if you can't add those in your head, but that is 110. So total, I'm just going to kind of write check. 56 plus 54 equals 110. Yeah, it is right. So if you did this check and you didn't get 110, then you need to go back and see, where did you make your mistake? Maybe you just made a little calculation error in here. Maybe you copied down a plus instead of a minus. Maybe you made a mistake solving the equation. But if you didn't get 110 here, you know you've got a problem. So you kind of got dimensions. You can find the perimeter of a square with a side length 14. You can find the perimeter of an equilateral triangle with side length 18. Do those perimeters work out to what was given in the original question? Always make sure to check your work wherever you can, and that can help you catch just some kind of silly mistakes, whether you copied something down wrong or wrote the wrong number or added when you should have subtracted, whatever it might be. So that is it for Unit 3, Day 3. We're going to move on and do similar kinds of questions, but where we have fractions in our polynomial equations in the next lesson for Day 4.